Okay, so I just took this example number 8, section 6.7. I just factored the denominator. So the denominator is x to the 4th plus 6x squared plus 9. This is like a perfect square trinomial. It factors into two binomials squared, but the binomials happen to be quadratic. So x squared plus 3 times x squared plus 3 would get this back again. X squared times x squared is x to the 4th. 3 squared is 9. 3x squared plus 3x squared is our 6x squared in the middle. If that makes sense. Okay, so then our least common denominator is this x squared plus 3 times x squared plus 3. We have our quadratic with a linear in the top, and then our quadratic squared with another linear in the top. I don't know why I wrote a 4 there instead of D. Let me fix that. And D it is. There we go. Okay, so then we have our least common denominator, which I've taken and multiplied each place. Let's go ahead and simplify that out. So this whole thing goes, how come every time I choose a different color, it does not take? Goodbye, goodbye, goodbye. All right, so what do we have left? We have x squared plus 5x minus 1. And then we have ax plus b times x squared plus 3. And then we just have cx plus d, because all of that one canceled out. We can go ahead and multiply this together, FOIL it out. So we've got ax cubed plus bx squared plus, so I did the a and the b, and now I'm doing the 3. So 3ax plus 3b. Right? And then we still have cx and d. That is equal to our x squared plus 5x minus 1. So gathering up terms, I have my x squareds. So I have 1 equals, oh, that's an x cubed. Scratch that one. We'll have to do that in a separate category. Okay, so b, and that's the only one, so there's b. That was easy. Okay, now let's do our x cubed. Wasn't paying attention when I realized I needed to make an x cubed grouping. So we have 0 on the left, and we have a on the right, so there's a. Some of these problems just fall apart. Okay, so then on the left we have a 5 for our x terms, and on the right we have this one and this one, so it's 3a plus c. Since we already know what a is, plug in 0 for a, so 3 times 0 plus c, that tells us that c is 5. And then our last one would be our constants. So that will be a -1. And we have negative, or not negative, positive 3b plus d. I already know that b equals 1, so I'm going to plug that in. So -1 equals 3 times 1 plus d. Subtract 3 from both sides, and d equals -4. So that ended up being like our easiest problem. We then have ax plus b. So a is 0, means I'm not going to have an x term on this one. B is 1, and then the denominator was x squared plus 3. So even though we have to do the linear thing over the quadratic, that doesn't always mean it will be a linear. Sometimes it'll still be a constant if the linear term is 0, right? We just have to plan for that, which is why we have to put a linear over a quadratic so that in case it is linear, we can find that value. Okay, so then c would be 5x minus 4 over this thing squared. And we are finished.